Hello class, this is a video tutorial on the inverse function. In this video we'll be looking at an example, well, three examples on the domain and range of the inverse. So in this video we'll be looking at one example on these three steps for this one, and in the next two videos we'll repeat it on different functions. So here's the second and here's the third. Okay, so let's get straight to it. So the first thing we're going to do is identify in this function that we have where it is always increasing. Because remember, when we do this, we make it so that it becomes a one-to-one, as in it passes the horizontal line test, because right now it fails. So let's identify where this function is always increasing. Well, as you can see, I've actually sketched it for us here. The stationary point is at x equals -1. So at that point, it's actually going from, take a look, negative tangents to a stationary point, and then positive tangents. Okay, so well, we can see that it is increasing from this stationary point and then to its right. Not including the stationary point though, because that would mean, well, a stationary point is not increasing. So we can say that it is increasing from x is greater than -1, or in bracket notation from -1 to positive infinity. Now that you've seen this, you can probably take a guess at when it is always decreasing. Well, if to the right it's increasing, as you can see from the graph, it's decreasing to the left of -1. So it's decreasing from x is less than -1, or in bracket notation from -infinity to -1. So now that we have this, let's sketch what the function, well, sorry, what the inverse of this function would look like. I have two graphs here because we're going to be sketching two different inverse functions. One of them is for when it's always increasing, and the other is for when it's always decreasing. Alright, so here we go. Let's do the first one for always increasing. As we've said, let's actually highlight where it would be always increasing. An open dot, because we're not including -1, and to the right. So that there in orange is the always increasing function of this parabola. So from here, let's sketch the inverse of the orange function. Let's switch now the x and y values here. Oops. So this point is going to become -4, -1. -4, -1 should be here. But just as this is an open circle, we're not including that value, so will the inverse of that function as well. So that's an open circle here. And for 1, 0, that will become 0, 1. And I hope now you can see the inverse of this function being drawn. Oh, I just realized also we could use the the y-intercept here. That's going to be at 0, -3. So the y-intercept would be at -3, 0. So it would look something like this. That there is our inverse of, because remember, it's just the orange part. Let's do now the same for this one here. You can pause the video and give this a go yourself. This is the always decreasing section. Like we said, it's always decreasing from -1 and to its right. That there. And just as before, it's an open circle, so we're going to do the same. So -4, -1, open circle. This point here, -3, 0, is going to become 0, -3. So with only 2 points, we're just going to have to work with what we have. It's going to be something like that. And that there's the inverse of the negative section of that parabola. Now that we have that, let's write down the domain and range of each of these inverse functions. So here we go. Well, the domain of this inverse, its x value here is -4. But since it's open, we do not include -4. So open bracket, -4, up until, and as you can see, it extends infinitely to the right. So we can take any x value to the right of -4. If you want to see this in inequality notation, it would become positive infinity, like this. Or, more importantly, you can just say x is greater than -4. As for its range, we can see that the y value that it begins in here is -1. So it begins at -1 and it increases infinitely upwards, even though it looks like it's going really flat. But still, it's increasing infinitely to, infinite. And you can try and figure out what the notation is for that one. So that there's the domain and range for this inverse function. Let's do one more. You can go ahead and pause and try and figure it out yourself as well. Well, for this, it's rather obvious that its domain is actually the exact same, because it starts at -4 and goes infinitely to the right. So, like so. As for its range, you can see that its highest value this time is -1. So its highest value is -1, but its lowest, just as the previous one, it looks like it's getting more flat, but it actually extends infinitely downwards as well, even though it looks like it's getting flat. So for this, its y value is going to be from -infinity up to -1, not including -1. So I hope that gave you an insight into restricting the domain and finding the range of inverse functions. See you in the next video. Best of luck.